electrical protection relays. See, I would like to have this session as interactive session, not mere spectators. So whenever I would like to ask some questions. I would request you to respond so that we can make it as a interactive one, right? Can I have some responses, please? Okay. So I'll go to the topic. So what is protection relay? See, it is all it's electrical device that is designed to respond some input conditions like in terms of some faults has happened to protect the human, to protect the machine. There has to be some protective relay. So it will sense a lot of inputs, be it electrical or mechanical or thermal, whatever it forms. It will take those inputs through via some limit switches, some sensors, some relays. So those inputs will be taken to a device, and that device will process those inputs, and at an appropriate time, it has to trip the mechanisms and save the human or save the machines. So that is the main objective of the protective relay. So what are the different types of protective relays? There are a lot of types of protective relays, which are protective relays. Protective relays is mainly used in the substations, in the distribution systems, where the electrical power is being supplied to the load. So in the event of any short circuit or any dangerous conditions, so in that time it has to the system has to give an alarm, or if it is more dangerous, then it has to trip the system. So there the protection relatives are used. And when it comes to monitoring relays, these are not very sensitive relays. Monitoring relays is in the sense it assesses system, be it a power system or a power distribution system or a motor protection system. It monitors certain parameters. Whatever parameters you would like to monitor, it will monitor, and whenever it reaches some threshold value, it will trigger you some information through your mobile, or through your email alert. So it will alert you this in some conditions. You have specified some conditions. That condition has it has reached. So that point in time, so the monitoring relay will give you information that this is going to be happen like this. So that those relays are called monitoring relays. And programming relays. So whenever you have a type of protection, you take some inputs, and according to inputs, you use your logic tables like truth tables, using your functions, digital functions like AND, OR, NAND, or NOT. So using these functions, you build a logic. So accordingly, this programming based on the program, some actions needs to be has to be done. So that kind of relays are called programming relays. And regulating relays are like, for example, if a generator is there, up to after some power cut, it has to start. So there the regulating relays will be used. And auxiliary relays are nothing but it's a kind of trip circuit supervision relay, some relays with digital inputs and outputs. So based upon which the electrical protection scheme can be arrived. So these are the some minimum relays are required to evolve the system. So these are the types of relay categories. So using which electrical system has been protected. And those relays, it can vary based on various type of inputs. So there are relays which are based on current based protection. There are relays which are based on voltage based protection, and there are relays which are based on different types of parameters like frequency, pressure, temperature. And every relay, it operates on some principle. Something will operate on percentage. If some percentage of current reaches, this has to operate. And some operates in the principle of electromechanical. Some relays will operate in terms of solid state. It is electronic protection. And With respect to performance, some relays will work on IDMT, that is inverse definite time over current. I hope you understand what is inverse definite time over current. The time, whenever the time increases, your current will be decreasing. So it's called in IDMT curve. And there are in overcurrent in numerical relay, there are also directional overcurrent and non-directional overcurrent. Wherever directional overcurrent protection is required, their voltage-based inputs are required. So based upon under voltage or over voltage, at fault, so these performance characters are defined, and accordingly the relays were selected. And earlier days, there are two type of protection relays. Earlier days, people use electromechanical relays. Electromechanical relays, you might be seen in our household earlier, like before 10 years or 15 years, you will be seeing like this type of relay, the lower one. So there, if you see, it's all works on like electromagnetic principles. So accordingly, the protections are offered to the system. It is like some minimum protections are only available, like overload or short circuit or earth fault. But in today's world, there are digital protective relays, so which are called numerical relays. So that uses microprocessor to analyze the power system based upon the voltage and current. It will detect the fault and it will clear the fault as quickly as possible compared to electromechanical relays. And it is also has the ability of monitoring, recording, and it has a lot of logics. It has digital inputs, digital outputs, based upon which you'll be able to do a lot of functions. So through the numerical relays, it is an advanced communications today's world. It has a lot of communication protocols like Modbus, TCP/IP, IEC 61850, Ethernet protocol. These are the protocols available. So using which we are able to analyze the situation. If some problem has happened in the past, why this problem has happened, what are the reasons under which this relays has tripped. So these data can be taken out in a software. You can analyze what type of fault has happened, why it is happening. So these are all the advanced digital protective relays available in the today's market. So electromechanical relays still for some protections, the bodies like CEIG is Chief Electrical Industrial body, which enforces some conditions for industries to follow. So some protection like earth fault relay, still people are using electromechanical relay, but in majority of protections, electromechanical relays has been replaced by numerical relays, that is called digital protective relays. Any doubt you guys have, can you please open up and ask, so that I'll be able to clarify you. Since the screen is visible to me, I'm not able to see what are the responses. Maybe if you open up and tell, I'll be able to get it. Brothers and sisters, unless you speak, I'm not able to understand. Samuel, sir?
No doubt, sir. You can proceed, sir.
Yeah, okay. So the numerical relays, how these numerical relays will operate. These numerical relays, it's a relay. Suppose there are also in power system, 110 kV systems are there, 132 kV systems are there, 33 kV systems are there, 11 kV systems are there, 415 volt systems are there. But numerical relays are like same. Then how do you give the inputs to the relay? Can someone confirm, please? Can the same numerical relay can be used for all whether the same numerical can be used for 11 kV panel and the 450 volt low voltage panels as well? If you ask me, the answer is yes. The name numerical release can be used, but the current transformer and potential transformer has to be based upon your primary voltages. If it is 11, suppose if your primary voltage is 11 kV, and thus 11 kV will be given to the potential transformer input, and the output it can be ranged to 0 to 120 volts, and these volts will be given, this voltage will be given to the relays, and based on which the relay will programmed. For example, if any kind of overload or short circuit happens, based upon the voltage levels in the primary side, the secondary side there will be no voltage, and by sensing this voltage, the numerical relay will operate, and it is equal. It is as equal for current transformer as well. How much? Suppose if any short circuit current of 50 kiloampere, 50 kiloampere is 50,000 amps. If some short circuit comes, and that will be changed to primary, there will be 50 kA, and secondary accordingly based on the ratio of the CT, the current will change. So if that current comes, then accordingly the relay will be actuated. Before moving to, I would like to understand from you which equipment will draw more starting current, whether it is motor, whether it is transformer, or whether it is any heating load. Which one will draw more starting current?
Motor, sir.
Don't you think transformers take more starting current? Why? Can someone explain me why motor drawing starting current?
Sir, rotating ஆகுறதுனால sir.
Rotating ஆகுறதுனாலயா? Can someone relate the electrical characteristics of the motor and confirm why motors taking starting current?
Initial torque அதிகமா இருக்கும் sir.
Motor can be no load also. That the motor can be the motor can be coupled to load or no load. In any case, the starting current it will take. Why? Okay, let me explain. It is like motor is nothing but your transformers secondary short circuited. You have a primary winding, and you are giving a supply of some 415 volt to the primary. In the secondary side, the electrical representation of the motor is like if you short circuit, if you close the secondary side of the winding, then it is called motor. So it is a representation of motor is like there is a stator you are giving a supply, and rotor is inside, and rotor is like a short circuited circuit. So when you apply voltages in the primary side, there is no EMF generated in the secondary side. So the principle of current flow is like whenever there is a high potential is there, and here it is lower potential. So the current will flow like high potential to low potential. And when there is a back EMF in the primary side, there is no back EMF in the secondary side. It tends to draw more current from the primary side. So that's the reason the motor is starting. It is drawing more starting current. Not only motor, transformer also takes more starting current, because when there is no EMF in the secondary side, in the primary side it tends to take more starting current. It will be ranges of 7 times of the rated current. Suppose if it is 10 kilowatt, suppose a motor takes a 10 amps, it ranges, the short circuit current takes in the range of 70 amps or 80 amps. Actually, it is allowed as per IEC 7 to 7.10, subject to IS tolerance for the motors. So whether the motor is in the load or not, it is not connected to a load, it will tend to take starting current because of there is no back EMF generated in the secondary side. Once the motor begins started, then slowly the back EMF also generated in the secondary circuit. Then slowly not slowly, it is a fraction of like if once the motor picks up 80% of the speed, 80% of the speed will pick up in more like in 2-3 seconds. Till the time the starting current will be there. Once the EMF is generated in the secondary side, then there will not be any starting current. Then it will be only the rated current what it can deliver. Suppose if a motor 15 kilowatt has 20 amps, that 20 amps will be taken by the motor during normal load conditions when the motor get loaded. And even it is load, if the motor is there is no load connected, some 30% of that, 30 to 40% of that rated current that will take. I hope this point is clarified, because why I am explaining this phenomenon is that see, basically 95% of the loads in the industries are only motors. So based on the motors only, the protection schemes are arrived in the industry. So and based on the starting current only, the various types of protections are introduced for motors. So this is a basic feature or phenomenon or characteristic you have to understood why starting current is, why it is the motor is taking starting current. So this is a basic fundamental characteristics which any electrical engineer has to be aware of it. I hope now you understood, colleagues.
Yes, sir.
Okay. So if you go for various types of applications in the industry, there are in the panels. In the panels means in our home we will be using 1 dB, but industry to power up those all those machines, they will be using a panels. In the panels, there are low voltage panels are also there. There are high voltage panels are there. When I say low voltage, it is 415 volt. When I say high voltage, it is like 11 kilowatt, 33 kilowatt, and more than that 110 kilovolt. So various types of protections are there. So these various types of panels are there. In these panels, if you see, there is all called some arc flash protection. So in the event of any arc is available for arc is produced, so that arc has to be sensed by like some sensors, and it has to quickly, it has to, before something worst happens, if some arc happens, based upon the lumens that it emit in the panel, that sensor will sense and it will trip. So those are called arc protection relays. And if we go for feeder overcurrent power feeder protection, there are overcurrent relays. So wherever there are overcurrents are there, to protect those machines, there will be overcurrent protection relays. So there are certain types of relays, and there are line differential protection which are applicable for any transmission lines, and for capacitor bank protection. So capacitor bank, why capacitor banks are used in industry? Why capacitor is required? Can someone confirm why capacitor panels are used in the industry? Why capacitor banks has to be part of the system?
Sir, power factor maintain பண்றது.
Power factor?
Maintain பண்றது.
Power factor, to improve the power factor? Can I take it as to improve the power factor?
Yes, sir.
Okay. Why we have to improve the power factor? What cost we need to improve the power factor? What generally motors are what type of loads? Whether it is resistive or inductive or capacitive?
Inductive load.
Inductive load. So the more the use inductive load, what would be your power factor in the industry?
Lagging power factor.
And it can be ranged from maybe approximately 10. What would be the inductive power factor?
0.8.
It will be in the range of 0.6 to 0.8. So, and what is the TNEB expects you to maintain power factor in the industry? What is the industry means? What is the TNEB or EB's expectation of industries to maintain the power factor in their system when they draws the power from their substation? So the industries have to maintain some power factor at their mains before their HT panels are starts. They have to maintain some power factor. So that is what is that expectation? EB's expectation. It is 0.98 to 0.99, close to unity but not unity. So in order to maintain 0.98, 0.99 power factor, this capacity, because I said most of our industries are run by inductive loads, that is motors. So in order to improve the lagging power factor to the closest close to the unity power factor, not the leading power factor, we cannot EB also give penalty when you maintain leading power factor, means above 1. Above 1 means you pump the power to back to the substation. It is not like that. So you have to maintain 0.98. In order to maintain 0.98, you have to add capacitor panels in every industry. So that calculation, how much to maintain 0.8, how much kVR needs to be pumped in, so that has to be calculated and put in. And there are also transformers to protect the transformer. There is a differential protection relay is there, and for motor and generator to protect, there are different protection relays are applicable. And high impedance, wherever the applications are with high impedance, their protection relays are there. And there is synchronizing in the sense, suppose I have taken a 2 MVA power from EB, and for 2 MVA that is an EB. If there is a power cut and I have 2 DGs, but in order to sync the 2 DGs, I need to maintain 3 parameters equal. What are the 3 parameters when you operate in parallel? Suppose if you have 2 sources you would like to operate in parallel. What are the 3 conditions we have to maintain? Can someone tell me, please? There are 3 conditions which we have to maintain to do a parallel operation. Okay, let me tell you. If you have to do parallel operation for 2 generator, first of all, the first point is the voltage of the each generator has to be same. And second one, frequency of the both generator has to be same. And third one, phase sequence of both the sources has to be same. These are the 3 conditions has to be met before we do parallel operation. For doing such thing, the result called sync relay is there. So this sync relay will check all these parameters. Then only it allows the DG power, 2 DG power to sync. So and this also have a lot of protections inbuilt. So this sync relay is used for synchronization of 2 sources or more than 2 sources. So these relays will be used for synchronization of 2 sources. I'll give you what is the portfolio of numerical relays used in industries. Basically with respect to after your distribution, like after the substation, EB people give 33 kV or 11 kV line. So they will be used for feeder protection. This feeder protection, if you see, this feeder protection, it offers overload protection, short circuit protection, earth fault protection. And in which if you see, according to the applications, there are fixer and draw out. Fixer and draw out in the sense, these relays are fixed and the wires are like physically connected. Draw out in the sense, there will be a casing will be there like cassette type. The relays will be inserted and it can be taken out. Suppose if there is a problem in the relay can be taken out easily, and other relay can be fixed inside. It can be inserted. So the wires to the relays will not be disturbed. So draw out relays are also available in the market. Fixed relays are also available in the market. And if you see in relays, fixed relays, there are non-directional relays are there, direction relays are there. Non-directional relays will use only current inputs. Directional relays will take current and voltage, both inputs, and understand whether it is what kind of faults it's facing, like overcurrent or earth fault or short circuit, depends upon the CT inputs, PT inputs. These relays will give a signals to the breakers to trip. And if you see motor protection, in motor protection, there are numerical relays available for protecting the motor. Generally, these numerical relays are used for motors generally 90 kilowatt and above in the market. And there are also transformer protections relays are available in the market, which is obviously directional based voltage. Transformer is basically it steps up voltage or step down voltages, and there are check synchronizing relays. So the relays can be used like this. See, after your transformer, the fader protection relays are used, and based upon if it is a power fader, same the numerical relays will be used, and if it is motor faders, those motor protection relays will be used. See, in IEC, there is an ANSI code for each and every protections available in the industry. So for each protection, like they have defined a number. So for example, it is a ground instantaneous overcurrent, then they have given a number is called 50G. And when it is a neutral instantaneous overcurrent, they call it as 50N. So for every protection, there is a number is generated. Suppose if a customer is asking for a relay, generally now the specifications for purchasing any relays, they will give you only the sequence numbers. So I want 50N, 50P, 50EF, this protection I want. So accordingly, people like us, we select the relays based upon the expectation of the customer. We will select the relays. So these are all like universal codes for applicable for all the manufacturers. So in suppose if a designer is designing an SLD, he will say he will put a numerical relay and he will write only these numbers. He will not write entire this description like this is neutral instantaneous overcurrent, this is phase instantaneous overcurrent. They don't write anything. They simply write these numbers. This numbers 50N protection I want. So this is how it is easier for the designer to communicate to the users what kind of protections they are required. My area of expertise is more on protections for squirrel cage induction motors. So though I am capable of explaining you feeder protection, how it is in the panels, but if we see motor characteristics, that is the main part which we need to understand. So there I have whatever in last 10 years I have worked. So then basically I have worked around squirrel cage induction motors, how to protect it, what kind of starting methods are available. So these are all my area of expertise. So I want to give a little bit information on squirrel cage induction motor, how these are all having a protection schemes. So I would like to explain it to you. This squirrel cage induction motors, if you see, the methods of starting is like DOL, star delta, soft starter, VVF drive. As I already told you, the starting current is major point with respect to motors. So there, based upon the starting current only, all these 4 types of starting has been explained. So direct online, star delta, soft starter, VFD. So direct online is what the supply will be directly connected to the motor. Only the contactors will be only one main contactor will be used. So directly the supply will be fed to the motor. Here the starting current will be like 7 times, 7 to 7.7 times, subject to IS tolerance. Tolerance is 20% plus, not minus. 20% plus is accepted as per standards. So when you fed the motor DOIL, the motor will take 7 to 7.7 times starting current. Generally in the market, up to people will allow up to 7.5 kilowatt only DOIL. Most of the small kind of industries, above which people will go for star delta starters. When you make star delta starter in the sense, you will use 3 contactors and you will be able to reduce the starting current by 3. Suppose your starting current is, for example, 6. Then if you use the starter, your starting current will become 2 times the starting current. But obviously, when the motor is started in DOL, the starting torque you will have around 2.7 times. Suppose if a motor exhibits 100 Newton meter torque as a starting as a rated torque, when the motor is started in DOL, your starting torque will be like 2.5 times into the 100 Newton meter. So it will be around 250 Newton meter. But if you take star delta starter, that starting torque will not be available to you. So 250 Newton meter again will be, we have to divide it by 3. So your starting torque also will come down in star delta. So wherever you have a low inertia loads, I'll tell you what is low inertia loads. So wherever the low inertia loads like fan, pump, these are all low inertia loads, where it will not there will not be more inertia when the motor gets started. So their starting torque is not very much secured. So their star delta starters can be used. And soft starter is like it is also like slightly VFD, but you will not be able to vary the frequency or voltage to the much. You will be able to play around like some 0 to 40%, 30%, 40%. That voltage ramp up, you can use slightly ramp up the voltage, and using which you will be able to control the motors. And variable voltage and variable frequency drives are quite famous today in the industry. So majority of applications, constant torque application, variable torque applications are driven through variable voltage and variable frequency. And the moment you say variable voltage and variable frequency, you are applying the voltage from 0 and you gradually increase the voltage. And there is no question of starting current in the VFD starting up methods. And if you take type of loads, there are 2 types of load. One is variable torque, one is constant torque. Variable torque is like, you have suppose if you have a 4-pole motor, and for 4-pole motor the synchronous speed is like 1500 rpm. Variable torque in the sense, it will from the 0 speed your torque is gradually increase exponentially. It will increase, and at 100% it will be rated the rated load, and it will operate in on that load. But constant torque loads is not like that. Even at a starting, suppose example conveyor, if the conveyor is there, the motor is driving the conveyor, and the conveyor carries the coal to a power plant. So when you start the motor, the coal will be available in the conveyor belt. So the motor starting with the load. So the moment at 0 RPM, the load will be like 2 times or 2.5 times based upon the load. So to start those applications, constant torque application, if you try to start in DOL or this thing, the motor tend to fail because it will not be able to overcome that inertia. So the generally constant torque applications are started through variable voltage or variable frequency drives. When you take squirrel cage induction motors, there is various types of faults are available, like short circuit, earth fault, overload relay, overload, phase failure, locked rotor, phase reversal. These are some faults which are applicable for squirrel cage induction motors. And for each fault, there is a protection device available. So for short circuit protection device, if you take fuses are available, MCB are available, MPCB are available, MCCB, ACB, numerical relay. So short circuit in the sense, it will be like in the range of 10 times the rated current. If any 10 times the rated current is there, or any fault, deadliest short circuit is like a 3-phase to ground. So if any 3-phase to any ground short circuit has happened, the fault current will be like whatever the transformer capacity. Suppose if you have a 2500 kVA transformer, it can pump around 57 kiloampere, 50,000 amps. It can pump into the feeder. So these devices has to be capable of carrying, sensing that current and trip the breakers. And if you see overload protection, in overload protection, if you see fuse, MPCB, thermal overload relay, microburst based overload relay, intelligent overload relay is nothing but these relays will have a communications options like Profibus, Profinet, Ethernet, Modbus TCP/IP, and ACB and numerical relay. And earth fault protection, basically, some devices will not have earth fault. For example, thermal overload relay will not have earth fault protection. But microburst based relay, earth fault relay, intelligent overload relay, ACB, numerical relay, this will have earth fault protection by default. So these are the relays. If you see, the first picture is like is a fuse. The second picture is MPCB, and the other picture is MCCB, ACB. These are the center one is numerical means intelligent relay. It has inbuilt communication protocol which will communicate to the SCADA systems. And there is a numerical relay. And the below whatever I have shown, it is the thermal overload relay and microburst based overload relays. So these are some quick I could able to share it with you. If you have any doubts, please openly tell me. Excuse me. See, it is a wide topic. It is very difficult to cover it in 1 hour. So I would like to suppose wherever there is any doubt, you can also reach out to me through WhatsApp. Maybe I can ask Hari or Samuel sir to give my number to you. You can WhatsApp me for any basic doubts in electrical protection with respect to relays. You can feel free to ask me. If best possible way, I will be able to help you.
Sure, sir. Students, do you have any questions?
Any doubt?
See, I would like to tell you, see, the people who are trying to pursue a career in the core side, you have to be thorough with some basic principles of electricals, like be it Ohm's law, be it how the what is inductive load, what is capacitive load, or how the power system. Slightly you have to brush up your basics. This will be very people who are you are going for any you are going to start a career with a small company or a big company. People expecting is that at basic one has to be thorough, and then basic is there. Generally people are confident about training them to next level. So I would request you to don't just go into a syllabus. Just you based upon the idea which I have given today, you slightly brush up the basics. So it will be easier for you to get into a next level when you start the career. Okay. So thank you from my end, Mr. Samuel, sir.
Thank you, sir. Now, Selva Kadirisan will deliver the vote of
Yes, sir. On behalf of all students and staff, I am glad to be standing here to express my vote of thanks. A special thanks to our chief guest, Mr.S.Murugaraj, honorable alumni of our department, for accepting our invitation and for being here with us today. Thank you, sir, for the wonderful session and our quality time with us. Thank you, sir. I would especially thank our HOD, Dr. Vilju Sirdeyarajan, sir, and our alumni staff coordinator, Mr. Samuel Pakinathan, sir, for organizing such a useful webinar. Thank you, sir. Finally, thank you all very much for being with us today. Have a wonderful day again.
Thank you.
Thank you, sir. Students, you can leave from this meet.
Thank you all. Thank you, sir.
Hari Krishna.
Thank you.
Students எல்லாரும் கொஞ்சம் செமினார் ஹாலில் வெயிட் பண்ணுங்க. இப்போ ஒரு 2 minutes நான் வந்துடுவேன். செமினார் ஹாலில் இருக்கு, நான் வந்துடுறேன் இப்போ.